So, even in this day and age, when renewable energy sources are growing in popularity and in supply capacity, the majority of the UK's power still comes from thermal power stations, like the one behind me. These power stations take a solid fuel, be that coal or wood, and create electricity. They convert the chemical energy stored in that fuel into electrical energy via a series of processes. Let's look at the start of the process. This is the furnace. Here we supply the furnace with fuel. The fuel will be made as small as possible to increase its surface area. This makes the fuel burn hotter, releasing its chemical energy as fast as possible, making our station more efficient. In the furnace, we burn the fuel, converting its chemical energy into heat energy. The next part is the boiler. This device is around the furnace, and it contains loads of small pipes crisscrossing the furnace. These pipes contain water. This water absorbs the heat released by the burning fuel and becomes superheated steam, way above its boiling point, somewhere in the region of 400 to 500 degrees Celsius. These pipes are very small and again have a relatively large surface area, maximising the rate at which heat can be transferred from the gases into the water. Once the steam is superheated, it's time it is put to work. This superheated steam flows into the turbines. These are giant fans which are pushed round by the steam really fast, somewhere in the region of 3,000 to 3,500 revolutions per minute. In these turbines, the heat energy stored in the steam is converted to kinetic energy in the spinning turbine. In a real power station, there can be 3 or 4 sets of these turbines, getting larger in size each time. They get larger each time because as the steam pushes the turbine, it loses some of its heat energy. So in order for turbines down the sequence to move at the same speed, they need to get larger to get the same push off the steam. These turbines are attached to the business end of the power station via a drive shaft. These are the generators. These generators contain coils and coils of wire, and they have an electromagnet inside the outer coils. As the electromagnet is spun, it generates electricity. Those doing separate science will learn how this works later in the year. So in our generator, the kinetic energy from the turbines is converted to electrical energy in the generator. Now, the iconic image of a power station is giant fluffy clouds leaving large towers like this one. Many people think this is the smoke from the burning fuel. However, it's not. Most power stations now have things in the chimney of the furnace to reduce the amount of smoke that they put out. It is in fact steam. These are the cooling towers, converting the waste steam from the turbines back into water to be used again by the power station. The steam you see is not the water used by the power station to generate electricity, because this has been super cleaned so it doesn't damage the insides of the power station. Instead, it's cooling water supplied from an external source, such as a lake, reservoir or river. Hence why so many power stations are placed in coastal areas. So our energy transfers are as follows. We started with chemical in the fuel. The fuel is burnt to convert this to heat. This heat is transferred to the water to create steam. The steam turns a turbine, converting the heat into kinetic energy. These turbines turn a generator, converting the kinetic energy into electrical energy, which is then supplied to our homes. So hopefully you now understand the processes in a thermal power station. and the energy changes that take place in them. These stations used to generate nearly all of the UK's power, and still though continue to generate a large proportion of the electricity we use, although now many of them have been converted to burn wood pellets and not coal. Gas turbine power stations, for example the local ones at Deeside and Connors Quay, they actually skip the furnace and boiler stage. Instead, they feed the gas straight into the turbine. Here it is burnt, and as it burns and expands, it pushes the blades round, generating electricity. Finally, in a nuclear power station, the furnace is replaced with a nuclear reactor. This is where uranium nuclei are broken apart, releasing heat energy which then boils the water. Thanks for watching this short video detailing the process of generating electricity in a thermal power station. You should have learnt the key stages in these power stations and the energy transfers that take place. If you like this video, please subscribe for more content highlighting parts of the WJEC, GCSE and A-level courses. Please leave a comment of future topics you want us to cover. Finally, again, thanks for watching.